Now, my homeboy, Captain Calculus, Patterns and Graphs, NCEA 1.3. Yeah!
Hello, this is another long form video. The last one was it was okay, so let's do another one. We're going to go to a different topic today. This is NCEA 1, so this is still pretty much algebra, but it's to do with graphing now. Think of graphing as kind of a graphical way of showing algebra. You can't really have graphs without algebra, and they show the algebra pretty nicely. So primarily we're going to be concerned with three types of graphs. We have the linear graph here, where it's pretty self-explanatory. The line that you produce is a straight line. We have parabola, which come from quadratic, so something x to the power of 2, x squared. And then we have exponential graphs, which we've touched on briefly but haven't really gone into. So this is the graphical face of those exponential formula and equations that we did before. Really what we're dealing with is functions. And think of functions as like this machine where we put an x into a machine, it goes around, and then it spits out a y. And when we come to plot those graphs, those points, it will form a line or a parabola or something else. So let's have a look at exactly what I mean by that. So here I have a spreadsheet. On the x-axis here, I've just put in -3, -2.5, so it goes up in 0.5 increments, all the way from -3 to +3. So I've set those. And then I've kind of come along and I've said, okay, by putting it into this box here, I'm going to say, let whatever goes in this box just be equal to whatever's in this box. So whatever's in this box is equal to whatever's in this box. And when we come to graph it, we get this nice straight line. Okay. What happens if instead of whatever's in this box being whatever's in this box or this cell, what if we say take whatever's in A2 and square it? And we do it for all of these cells. Okay, we get something different. So it's a bendy curve. So 9 is -3 squared. Remember, -3 times -3 is +9. And then it goes down to 0, and then it comes back up again, and it's symmetric. 0, 0.25, 0.25, 1, 1, 6.25, 6.25, 9, 9. So notice here it kind of, if you look closely, it kind of kinks. If we put more and more and more points in here, it's going to eventually become this nice parabola that we had before, and a different type of parabola there. So let's continue with some more patterns. The next pattern I'm going to put in here, instead of taking whatever's to the left of it, I'm going and squaring it, I'm going to say that whatever's in this box here is going to be 2 to the power of whatever's in this box. And I'm going to copy it across. and it has the shape, and we've already seen the shape before. Think of exponential growth. So something doubles every time period. It crosses there at 1, 2, and another one up it's 4, another one up it's 9. You can't see the 9 there. Can't see the 8 there, sorry. So this is an exponential growth. What would happen if instead of having 2 to the power of the square that's to the left of it, what if we used 0.5 to the power of the cell which is immediately to the left, and then did that for all of these other, nope, copy that down, and there we go. We would have an exponential decay, and we already did this. This is, remember the Rutherford graph. So something loses its radioactivity, it emits radiation at a decaying rate. This is that graph. So notice that this is from algebra, this is from graphs. The graphs are not the algebra. They can't exist without the algebra, but they are kind of the other side of the coin of algebra that show us what's happening. Our brains think often visually, especially with maths, and graphs show that. We're going to be doing straight lines first. But first, I just want to introduce some software that we will be using. They're both free software. The first one is a website called GeoGebra. You can download this or you can do it online. I'll leave the link in the description. What it is, it's a suite of tools, but the most useful is the tool that we're going to be using now. And what it does, it lets us, if you look in the top here, it lets us enter the equation of the graph that we want to graph, and it just does it. It's very, very simple, quite user-friendly, quite forgiving. And one thing I can really stress is when you're wanting to learn graphing is to just get something like this and just play around with it. You can't break it. Just put in different values. Say if we wanted to say what would happen if we added 3, what would happen to this line? It's just a really, really nice way to learn. It's just to sort of mess around with it, see if you can break it. I doubt whether you can. The other software that we're going to be using, and I'm going to be using it now, is a website called PHET, P-H-E-T, and I'm also going to leave the link below. It has a whole bunch of these simulations, but this one is a particularly good one. We have y equals mx plus b. Now your books in school will probably have y equals mx plus c, but it's an American piece of software, so they use b. And this just lets us play around with straight line formulae just to see what happens. Okay, watch what happens as we increase m. Now m is the gradient, so as m goes up, as m increases, so I increase it to 2 over 1. Notice that means that for every 1 that it goes across, it goes up 2. It goes across 1, up 2, across 1, up 2, forever and ever. Alright, fair enough. So as we increase, it gets steeper and steeper. So the bigger the gradient, the steeper it is. What if, though, what if it wasn't a whole number? Say if the gradient was a half. Notice what happens there. As the number gets closer and closer to 0, it gets more and more shallow. So for every 4 that it goes across, it goes up 1. And it's no coincidence that it's 4 under 1. 1 over 4. And it's often described as rise, the amount that it rises over the amount that it runs. Fair enough. What about, though, if this becomes a negative number? Well, then it slopes the other way, and this is called a negative slope, a negative gradient. If m is a negative number, it will slope downwards from left to right. So the way to sort of remember it, just imagine a little man or a little woman running across from left to right. If they have to run uphill, it's a positive gradient. If they have to run downhill, it's a negative gradient. So the number in front of the x, the coefficient, the gradient, is the steepness. Fair enough. Now I'm going to set this back to 1. Now, watch what happens when I change the b in this case. They call it the b, your book will call it c, the constant term at the end. Watch what happens to the graph here as I change this number. So negative number means that it crosses the y-axis below the x-axis. And as it gets closer to 0, it gets closer to 0. And now that it's just mx plus 0, it crosses the origin point, the 0, 0, where x is 0 and y is 0. And as it gets larger and larger, it goes up and down again. So the b here at the end is the y-intercept, where the line crosses the x-intercept. So say I wanted to create a graph and I wanted it to have the gradient of 4 and to cross the y-axis at -2. Well, the gradient there is 4, and I want to move it down 2 places. Now we have a graph that has a gradient of 4. For every 1 that it goes across, it goes up 4, cross 1, up 4, and it crosses the y-axis there at -2. The picture on the right here is Baldwin Street in Dunedin. It's regarded as the steepest street in the world. It's contested, but it's generally acknowledged as the steepest street in the world. What we have on our left is the gradient point, gradient intercept form of a straight line, where m here is the steepness and c is the y-intercept. So m is the gradient, the steepness of the line. So as m gets bigger, the line gets steeper. So Baldwin Street has a gradient like that. So that's going to be, technically from our perspective, a negative gradient. For every amount that you go across, you go down a certain amount. So change in x over change in y, the rise over the run. The C bit here is the y-intercept. That is, where does the line cross the y-axis? So notice that as C goes up or down, this graph will move up or down, just like it did in GeoGebra. Let's say we have this equation here, y equals 3x plus 3. And I want to find out where it crosses the x and the y axis. So I have the x axis and the y axis. Where does it cross? So what is this point here and this point here where they cross? Well, I'm going to give you the rule. To find the y-intercept, we set x equal to 0 and solve for y. And conversely, to find the x-intercept, we just do the opposite. We set y equal to 0 and solve for x. Okay, let's do that in this case. So let's set y equals 0 and solve this equation for y. Sorry, we'll set x equals 0 and solve it for y. So y equals 3 times 0 plus 3. There's an x there, so we're going to put in a 0 there. So 3 times 0 is 0. And 0 plus 3 is 3. So this crosses at 3. But we kind of already knew that, didn't we? Because we know that this constant term at the end here is the y-intercept. Fair enough. Now let's set y equals 0 and find the x-intercept by solving for x. So y equals 3x plus 3. So y equals 0 now. We're going to set it equal to 0. 3x plus 3. And I want to solve for x, so I'm going to take 3 away from both sides. So 3x equals minus 3. I'm going to swap sides over. Divide both sides by 3. And negative 3 divided by positive 3 is negative 1. And if we go onto a spreadsheet, any spreadsheet will do this. So it was a 3x plus 3. So what I'm going to do is I'm going to tell whatever's in this cell here, take whatever's to the left of it, which is the x value, put in that number and get 3 times whatever is in that cell plus 3. And it's going to go away and it's going to find it for us. And it didn't really map it for us all that well, so let's copy it down. There we go. So notice there that when x equals 0, y equals 3. And we already know that. We worked it out. It doesn't show it all that well on this because it's not really a mathematical software. It's accounting software, really. And where y equals 0, x equals -1, it works. And if we were to do it on GeoGebra, 3x plus 3, here's where it crosses at 0, 3, and where it crosses the x-axis, it crosses it at tricky, -1, 0, which is the x-intercept. Notice that y is already 0, set to 0. -1, 0 when y equals 0. Okay. Let's do another one. We're just going to practice lots of them. So we want to find where this crosses the x-axis and where this crosses the y-axis. Well, I'm going to solve for the y-axis first. So y is going to be equal to 6. And when we find the y-axis, we make x equals 0. So y is going to be 6 times 0 minus 2 is -2. Fair enough. So we know it crosses the y-axis of -2. But I mean, again, that's not exactly groundbreaking, considering that we already worked that one out. Now let's find where it crosses the x-axis. So where it crosses the x-axis, y equals 0. So 0 equals 6x minus 2. I'm going to add 2 to both sides. And then I'm going to divide both sides by 6. And when I do that, they're going to cancel, and 2 over 6 is the same as 1 over 3. So in other words, this is going to cross the x-axis at 1/3, 0, and it's going to cross the y-axis at 0, -2. And again, let's do it on our spreadsheet. So it was 6x minus 2. So I'm going to say to this one here, take whatever's in the cell next to it, and then take 2 away from that. And I'm going to copy that down so it does it to all of these cells. And we get this nice graph. And we see there, sure enough, when x equals 0, y equals -2. And where y equals 0, well, it's going to be somewhere between those, somewhere between half and 0. We worked it out as 1/3, which is indeed halfway between. And then on GeoGebra, we're going to zoom out a bit. So here it is here. The root, which is the x-intercept, is 0.333, so 1/3, 0, and the y-intercept is at 0, -2. And let's do one more. So again, we're not even going to bother solving for y now. We just know that it crosses it at +3. So let's find the x-intercept. The x-intercept is where y equals 0, so I'm going to set this equal to 0, because y equals 0 if we cover this up. So -4x plus 3 equals 0. I'm going to take 3 away from both sides. They're going to cancel. -4x equals -3. It's x times -4, so I'm going to divide by 4. A negative divided by a negative is a positive. 3/4, which in decimal is 0.75. And let's just jump straight to GeoGebra. sure enough, it crosses the y-axis here at 3. And it crosses, well, we said it was 0.75, so it's going to cross it at, gives it to me, 0.75. So the long and short of it is that we take this, if we're wanting to solve it, we change it from a graphical problem to an algebra problem. You can't do graphing without doing algebra. They're two sides of the same coin. When it comes to lines, there are two formula that you really need to know. The first one is m equals y1 minus y2 all over x1 minus x2. And the other one is y minus y1 equals mx minus x1. They will give you these formula, but you need to know what these actually mean. So what does the m mean? Well, we should know what the m means. It's in our formula mx plus c. It's the same m, and if you remember, it's the gradient, the steepness. Okay, what do these x1, x2, y1, y2, what do they mean? Well, the best way to illustrate it is with an example. If we have 2 points, let's say 2, 3, and I'll make it easy, and 0, 0. And I want to draw a line that goes through both of them. What would be the equation of the line that goes through both of those points? Well, the first thing to do is to find what would be the gradient of that line that goes between them. And I'm going to say that this point is 0.1 and this point is 0.2. So the x value that belongs to 0.1 is 2. The y value that belongs to 0.1 is 3. And the x value that belongs to the second point, that's what the little subscript 2 means, is 0. And the y value of this second point is also 0. And now we have everything in this equation except for m, which we're trying to find. So what would we do then? Well, let's move it up a little bit. The gradient here is going to equal y1 minus y2 over x1 minus x2. It's the same. If I move that down for a sec, it's the same equation. So that's going to be y1 is 3 minus y2 is 0 over x1 is 2 minus x2 is 0. So it's 3 over 2. So the gradient of that line is 3 over 2. So for every 2 that it goes across, it goes up 3. That's 3 there. Just to rub that out, just to make it all good and nice. Right, now that we know the gradient, now we can apply this second formula, second equation, to find what the actual formula for that line is in this form here, in this y equals mx plus c form. And y minus y1 equals mx minus x1. Just a bit of a tip. Whenever you use a formula or an equation, always copy it down. Don't sort of jump straight to the numbers. It's often a rule. It's often a sort of recipe for disaster when you do that. So just have the formula that you're using right there so you can just substitute the values straight in. So y is just y. y1 is 3. It's right here. M is 3 over 2. X is x. And x1 is 2. And now we're almost there. Now it's no longer a graphing problem. Now it's an algebra problem. So I'm going to keep that -3 there for now, but I'm going to expand out this bracket. So 3 over 2 times x, and I'm going to leave it in this form here. And I'm going to leave it as an improper fraction because that's actually more useful in our case, because that tells us straight away what the gradient is. It's this 2 over 3 business. And 3 over 2 times -2 is -3. And now we're almost done. We're almost in this mx plus c form. We're almost here. The only step that we need to do now is to add 3 to both sides. And the result of that is that this -3 and +3 are going to cancel. So our final answer is going to be y equals 3 over 2 x plus 0. If we wanted to put that in, and then it tells us that it's going to cross at the origin point, at the point 0, 0. Which I guess I already gave you there. So I want to sort of keep it in that form there. Let's go to GeoGebra and let's put that in 3 over 2 over x. So y equals, and I'm going to put it in this form here. It's just the form that GeoGebra works best with. And here we see again. Just make that a bit thicker. So the straight line goes through the origin point here at 0, 0. And for every 1 that it goes up a certain amount. Fair enough? Okay. We could also do this on your FX calculator if you're using one, and I'll show you how. We're going to go to menu, and I'm going to go to the stats setting. Well, you might be saying to yourself, well, this has nothing to do with stats. In effect, we're doing a linear regression. If you're interested in the correct term, I'm going to hit exe. And what I'm going to do, I'm going to put it in this form here. So I'm going to have 2, enter, 0, enter. Then I'm going to go across. Have to enter it first. I'm going to go across, and 2 and y1 is 3, 0. So notice how this form here matches this form here. I've kind of like put this 0, 0 underneath it. Then I'm going to go to F1 for graph, F1 again, graph 1, F1 again for calculate, and F2 for X, which means a linear regression. And I'm going to hit that, and it's going to give us the equation. So it tells us that y equals a, and for whatever it is it's calling it a, it's the gradient m. 1.5, well, 3 over 2 is 1.5. B is 0, and we know that, we worked that out, and it will even draw it for us. We can also use tables on this as well, but I'm not going to just yet. Let's do another one just so we can get in the habit of being able to do them. Let's use a slightly tougher example. So say I have the points 10, 5, and 4, 6. I should have thought them out beforehand, but okay. So 10, 5. So the first thing we're going to do is we're going to sort of apportion what these things are. So that's x1. That's x2, because this is point number 1. And this is point number 2. So this is going to be x that belongs to the second point, and this is going to be y2, the point, the y coordinate that belongs to the second point. Okay, first thing we're going to do is we're going to find the gradient. So m equals y1 minus y2 over x1 minus x2. And by the way, it doesn't matter which order you do these in. You could also do as long as you have the 2 over the 2 and the 1 over the 1, we'll be fine. But I'm going to use this first one for now. So y1, oh, that's y1, sorry. Oh, that was a mistake. So y1 is 5 minus, and y2 is 6. x1 is 10. x2 is 4. So our answer is going to be minus 1 over 6. And I'm going to leave it in that form there. I'm not going to turn it into a decimal number for two reasons. When I have 1 over 6, it's going to give me an awful surd number that's going to go on and on and on forever. But also I know now what's going to happen when I come to draw this graph. For every 6 that I go across, it's going to go down 1. So our line is going to kind of look like that. Quite shallow, but still negatively sloped. Remember, if the little man is walking, he's walking from left to right. If he's walking downhill, it's a negative slope. Right, now that we know what the gradient is, now we can apply our formula. So if you can't remember that formula, y minus y1 equals mx minus x1. So y minus y1, well, we know from this that y1 is 5. M is negative 1 over 6. X is x, and x1 is 10. And I'm going to expand out these brackets first. And I'm going to leave it in that form. Now, minus 1 over 6 times minus 10 over 1. That's going to be 10 over 6. Remember, negative times negative is positive. And now we're going to add another 5. So our final answer, when we come to do it, I'm just going to grab a calculator. So we want 10 over 6 plus 5, 20 over 3, and I'm going to leave it as 20 over 3 rather than converting it, because when we do that we get this nasty number here. So 20 over 3, and that's our final answer. So our final answer is y equals -1 over 6x plus 20 over 3. And again, let's go into the calculator and work this out from first principles. Go to menu, we go to stats, we need to clear everything off. 10 and then 4, go across, 5 and 6. We go to graph, calculate, straight line, and it's given it to us in this sort of horrible kind of version there, but it's the same as we got, and sure enough, the graph that we produced there is pretty similar to the one we thought. Point A here is on the y-axis at 6, and point B here is on the x-axis at 3, positive 3. What is the x coordinate of this point here, point A? Well, it's at 0. The y-axis is x equals 0. In fact, I'm going to show it for you now. X equals 0 is on top of the y-axis. And conversely, this point here, point B, is 3 to the right, but it doesn't go up or down at all. It's at 3, 0. And just to show you, that's y equals 0, is on top of the x-axis. So what would be the equation of the line that goes through both of those points? That is that line there. Without cheating, it's right there. How would we find that out? Well, point A here, the x value is 0, but the y value is 6. So this is point 0, 6. Point B here has no y value, but its x value is 3. So this is the point 3, 0. And it's exactly the same as any other graph. We just put in the 2 points and get the answer. So let's do that now. So we have the 2 points 0, 6 and 3, 0. I'm going to say that's x1, that's y1, that's x2, and that's y2. And just as normal, the gradient is y1 minus y2 all over x1 minus x2. y1 is going to be 6, we've got that there, minus 0, that's y2, that one there. x1 is 0, and x2 there is 3. So 6 minus 0 is 6, 0 minus 3 is minus 3. Positive number divided by a negative number is a negative number, so we know that the gradient of this line is -2. Now we use this formula. And I'm going to use the second one because the y value is 0. So y minus 0 equals -2, x minus, and x2 is 3. So when we come to simplify it, we get y, because y minus 0 is y, and we expand out the brackets, -2x, -2 times -3 is +6. So the equation is y equals -2x plus 6. And if we go to GeoGebra and plot it, yep, sure enough, it goes through both of those points. How would we do it on the Casio calculator? Well, let's do it. So we know that this point, this line goes through these 2 points. So I'm going to go to All Clear, Menu, and remember I'm going to go to Stats, and I'm going to enter like so. And 0. So you notice these two line up here, 0, 6, 0, 6, 3, 0, 3, 0. Might be a little bit hard to see it. I'll see if I can zoom it in a bit. And I'm going to enter exe, F1 for graph, F1 again, calculate, and I want a straight line x. And sure enough, the gradient is -2, and it cuts the y-axis at 6, and it'll even let me draw it. And that looks remarkably similar to that. Different scale, or maybe,
Yo, check it. My man Captain Calculus has done his intro to straight lines. Stay tuned for what's next. Parabolas.